So there is a restoring force that brings the coil back to its original position, and then because of the change, this part is going to flip the direction so that it rotates completely 360 degrees. So I've got two very good videos. I would suggest you guys to watch those videos as well. Uh, they're short videos, so just give me a second. You guys want to watch it right now or after the class?
Sir, after the
Ah,
these are explanation.
some okay. So one video is from the cognitive, and the other one is from the free lessons science. So these are the two best videos I've found so far. So please do watch them for your concepts. Okay, all of you. The ones who are not in the group, please let me know so that I can share with you guys as well. Sector. Zainab and Ali. Okay, so the video links have been shared. Please do watch them. And now we are moving towards something that is really, really important, and it's called the electromagnetic induction. And this is going to tell you about how the transformer is going to work, and this is the most important thing. Okay, so now, my dear students, what is electromagnetic induction? जी एसी मोटर नहीं होता, एसी जनरेटर होता है। एसी जनरेटर से पहले आपको इलेक्ट्रोमैग्नेटिक इंडक्शन पढ़ना जरूरी है, ठीक है। एसी जनरेटर जो है, इट इज एसी एसी जनरेटर, ठीक है, ऑल्टरनेटिव करंट जनरेटर। उससे पहले आपको ये जनरेटर इफेक्ट पढ़ा हुआ शायद, ताकि आप समझ लें। देखिए, so you've got a solenoid or a firing or a coil, ठीक है। And then what you do, you're done, you've got a galvanometer. Galvanometer is an instrument which can detect small current, okay? Which can detect small current. It has a needle, and that needle can show that some current. Galvanometer. If you guys remember when we were doing electricity, I told you guys about the symbol of this. Okay, now there's something really important. Listen. If I'm going to put a magnet like this, okay, but there is a condition that either the coil should move or the magnet should move, okay?
Okay.
So basically what I'm doing, I'm going to push and throw the magnet inside the solenoid, okay? So when the magnet is moved, across the solenoid, so what's going to happen when you're moving the magnet? Okay, so can you imagine that there are magnetic field lines? Okay, those field lines will be going, but now you have made some hindrance. ठीक है, अगर आप magnet को move करते and there was nothing in between, so the field lines must have gone straight away. But now what you have done, you have obstructed the field lines. Okay.
Yes, sir.
So always you are going to use the same terminology. Okay. When the magnet is moved across the solenoid, so magnetic field lines are cut. Okay, cut by what? By the solenoid, by the wire, by the coil, and that coil is a conductor. Okay, a magnetic field has a cut. Okay, and EMFs. EMF is the electromotive force. Okay, देखो जब एक energy, there is an energy. I'm telling you, just wait. There is an energy. If you want to stop that energy is going to transform into another form. So what is happening? That this magnetic force, when it is obstructed, so it will start making the electrons in the conductor move. And now there will be current in the coil, and now this the galvanometer will deflect. Are you getting? So when you're moving a magnet across a solenoid, and the solenoid is being connected to a galvanometer, so by moving the magnetic field lines are cut by the solenoid, and the electrons in the solenoid will start to move because they have a force. They have now a driving force, the same as the electromotive force. Okay, and that is going to be making the electrons move. So what's going to happen? An electromotive force is induced in the coil, and the galvanometer shows diffraction. This is what is called the but as soon as you make the magnet stationary, there will be no deflection. Okay, please remember this. So there must be continuous motion. Okay, one more thing. Deflection of galvanometer will always be opposite to direction of movement of magnet. Okay, like if the magnet is moved in this way, like this, okay, this way. Just imagine that you're pulling it in inward. Okay, so if this is moving like this, okay, so the galvanometer will deflect like this. Okay, if you're making it move like this, so the galvanometer. So if this is the direction, okay, so current is always going to be produced in the opposite direction. Galvanometer shows the other way. So if this is the movement towards, if this is the movement towards left side, the galvanometer will deflect towards right. Okay, and if it is moving towards right, then galvanometer will deflect towards left. Remember this. One more thing. That the side from which you are inserting the magnet will have the same polarity. Like if this is north, this will become north, and this will become south. So you will experience a small push or repulsion. Okay, so you have to apply some force to insert it. Are you getting?
Yes, sir.
Okay, so this is the thing.
सर नॉर्थ साइड के लिए गैल्वेनोमीटर नीडल ऑपोजिटली डिफ्लेक्ट होगी
नॉर्थ साइड के लिए ऑपोजिट होगी, वही तो बता आपने मैं कि जब आप नॉर्थ को इंसर्ट करोगे तो वो दूसरी साइड पे जाएगा,
और साउथ के लिए एक डायरेक्शन में.
अब जब आप उस तरफ से उसको फ्लिप करके दूसरी तरफ से इंसर्ट करोगे और आपने अच्छा अब क्या है, जब देखो नॉर्थ तो उस वक्त बनेगा ये जब आपके पास ये वाला नॉर्थ उसमें इंसर्ट होगा. व्हेन यू आर इंसर्टिंग द साउथ पोल सो इट विल बिकम साउथ. ठीक है, दूसरी तरफ से अगर मैं दूसरी तरफ से इंसर्ट करता हूं तो अब दूसरी तरफ पे वो नॉर्थ बन जाएगा. ठीक है, फॉर इंस्टेंस इफ आई एम इंसर्टिंग द नॉर्थ पोल inside it, okay, so this is going to be north and that's going to be south. अब एग्जाम में they ask you a question that how can we reverse the direction of the galvanometer? Say it any two ways. Yes. Okay. One. One more. What's going to happen that if we use the same side but the different opposite pole of the magnet? Hmm. Okay. This is the thing. They ask a question in which you are having. Okay, you guys have to tell. This is a plastic tube, and this is a metal tube. Is Ziad in the lesson or he's left?
No, I'm here.
Okay, that's great. So you just not have to tell the answer, but the explanation as well. Okay, because this was a 3 marker or 4 mark question, so you have to tell. Okay, my dear students, which of the two scenarios will have the magnet fall faster to the bottom? Yes,
Plastic.
good. Plastic. Why? Why?
Sir, temporary magnet. Hey,
Yes, please. I want a clear clear explanation for this. Shazen, आप बताइए. Okay, how many? Let me see. Let me see. How many of you are saying it's going to be plastic? Raise your hands.
What's the question?
The question is that out of these two, in which case is the magnet going to fall faster to the bottom? Is it going to be plastic or is it going to be the metal?
Metal.
Metal faster. Why?
It's going to like fall towards the metal, right?
It's going to fall towards the metal, but because when it is moving, it's in motion, it's not at rest. Okay? So when it's motion, so the magnetic field lines are cut, and you will have electromagnetic induction. Although magnetic field lines are cut over here as well, but plastic is a bad conductor. It's an insulator. It's a poor conductor. So what's
Yeah,
going
so
to
it won't
happen?
be able to
That
attract this. So then this will
so
fall.
this faster exactly. So this one is going to be in the North Pole, isn't it? Are you getting? You just studied that the side from where we are, yeah, you will have some repulsion. So the repulsive force will not be the repulsive force will not be so big that it's going to make the magnet fall out of it. Okay, but you will have the magnet, like the pace of the magnet will be slower, but still the magnet will fall down. Okay, because of the gravity, it's going to fall down. But this will have the magnet move faster because there will be no electromagnetic induction. Although the field lines will be cut, okay, but plastic is not a good conductor, so we cannot say that this is going to be the North Pole. This won't be a North Pole, so no attraction, no repulsion, is going to fall down. All right, is it clear?
Yes, sir.
Okay,
जी
it's so important, so important. So you must remember, they do give you questions like this. Okay, so you have to remember this. So wherever the magnetic field lines are cut, okay, they can ask you about the positions at this position. So you must remember that if something is moving up and down, is moving up and down. For instance,
No.
there's a spring, and a magnet is connected to the spring. Okay. So my dear students, at the highest point over here, when the spring is there, the field here is the metal where the magnet is to be placed up. Okay. So this one, okay. So let me give you 3 points. And this is moving in and out. Okay, this is moving in and out. So let me search for this question once I have this, so that will be more clear. So you guys need to remember that when the magnet is at the highest position, okay, the field lines are not cut. And when the magnet is at the lowest position, the this is going to lie inside the magnet. But when it is at this position, okay, the magnet is falling down. So at the middle position, the field lines are being cut. So if there is any question like this is a multiple choice question. So you have to choose the middle point. Please remember this. You have to choose the middle point. Is it clear? Why? Because at the yeah, because at the topmost position, the field lines are not cut. At the lowest position, the magnet is inside the coil. At the middle position is coming, so the field lines are cut, and the galvanometer is going to show the deflection. Okay, as soon as the magnet is going to come to rest, the galvanometer will stop because this EMF is so small. We cannot light a bulb with that. Okay, it's just a small current. Okay, but if the rotation is so strong, and if the like what you can say, do you know how the generator works? The generator provides the EMF or the push or the voltage. Okay, you put the oil in it, you put the fuel in it, the generator starts working. And what it does, the same thing is happening in the generator. Are you getting? Yeah, to produce electricity. So basically, the generator is not producing electricity, but it's providing the EMF to drive the electrons. That oh, देखो होता क्या है? जब घर की लाइट चली गई ना, so the electromotive force is not there, the voltage is not there. Actually, what is happening? The electrons are still there, but the voltage is zero. There is no potential difference, and there is no electricity. So basically, the generator provides the electricity, the potential difference, and then the electrons again start moving, and the appliances get turned on. Okay, so this is the phenomena of generator effect. Okay, and I hope all of my students are now clear with this. Can you move on?
Yes, sir.
Okay, done. Shazin, तुम खामोश हो यार, कुछ तो बोलो. Near the class.
Yes, sir.
Okay. अली समझ आ गया? चले आगे?
जी सर.
Good. ठीक है. So I'll just have a quick recap. Whenever a magnet is moved across a coil, and the magnet is moving, okay, so the field lines are cut, and you will say that there is an EMF induced in the coil, and the galvanometer will move. So if the magnet is pushed like this, so galvanometer move like this. If the magnet is taken away, so galvanometer move like this. Okay. याद रखना है कि magnet की movement and the direction of galvanometer deflection are going to be opposite to each other. This is called the Lenz's law. You need to study that in your A levels. Okay, but right now you must remember that. Okay. So now we have done this. Okay. Left hand rule was done yesterday. Right hand rule was done yesterday. We have done electromagnetic induction. Now we're just going to quickly go into the AC generator. AC generator is going to be there in the same exam notes as the next one. AC generator is so important here. Believe me, please. You guys, please, very carefully have a note of everything that I'm telling. So, O levels वाला कौन है? अमान है क्लास में?
सर मैं क्लास में हूँ।
ये कहाँ चला जाता है ये बच्चा? तुम हो क्लास में?
जी
शुक्र.
सर क्लास में।
हाँ, आप छोड़ के नहीं जाना क्लास बीच में से. फिर मैं
सर,
तुम्हें
नहीं
घर से
छोड़
पढ़ के लाऊंगा.
नहीं, सर।
तुम्हारे पास एक एक्स्ट्रा टॉपिक है रिले का. ठीक है, रिले इज नॉट देयर इन ऑल IGCSEs. I'll teach you relay separately, okay? Inshallah, either today in the class, you can stay after the class, or sometime later. It's a very small topic about relay and cathode ray oscilloscope.
सर मेरे में
Cathode
भी
ray
relay.
oscilloscope I'll teach to all of my students because relay है. ठीक
जी
है,
सर
तो
मेरी
relay
बुक
से
में.
सबको पढ़ा दूंगा फिर. ठीक है. रिले मेरे ख्याल से अच्छा मैं देख लेता हूँ स्पेक्स के अंदर 065 के. ठीक है. तो अब जरा प्लीज गाइस बी विद मी. This is your AC generator. Okay, you can be asked to label the parts so you can see that AC generator does not have electricity provision. It is basically providing electricity. So the coil will rotate and okay. So what's the difference between a motor and a generator? A motor basically converts the mechanical energy into electrical energy. No, reverse the thing. A motor converts electrical energy into mechanical energy. हमारे घर का जो motor होता है, the purpose is to lift the water from the underground to overhead. So basically, it's doing electrical energy conversion into mechanical energy by the movement. Generator is basically converting the motion into electricity. Okay, so it's the reverse of a motor. Okay, so what are the parts of this? You've got slip rings. Okay, there is no rotation, like there's no flipping of the sides of the coil. Okay, there's nothing like that. And for the AC generator, we are going to use the right hand rule. Instead of the left hand, we are going to use a right hand rule. Okay, so the AC generator is basically converting the motion into electricity. Okay, so screenshot करते हो या
सर आपकी आवाज कट
स्क्रीन बंद हो गई मेरे पास तो आ रही मेरे पास तो आ रही क्या नहीं मेरे पास आज दिक्कत है इसलिए चलो डन स्क्रीनशॉट टेकन
Yes, sir.
सर स्क्रीन शो नहीं हो रही.
आ जाओ यस तो वेट please take a note of everything okay there's a permanent magnet there's a rotating coil to cut the magnetic field. Because the cutting is so important, okay? Magnetic field lines must be cut to produce the voltage. If they are not cutting, there's no voltage. Slip rings allow the alternating current to flow between the coil and the external circuit, and the carbon brushes to provide good electrical connection. Okay, these are the functions which you can be asked to write down. Please have a note of this. Screenshot. How the AC generator works. This is the most important part. यार ये याद करना तुम लोगों को सही है ये कर लोगे उसके बाद ट्रांसफॉर्मर कराऊंगा इंशाल्लाह होगा रिले छोटा सा टॉपिक है और इसके अलावा कुछ भी नहीं इसके अंदर कुछ चीजें जो याद करनी है like there are a few things which you guys need to remember parallel perpendicular and this is going to affect the graph okay affect this graph so please stay with me I wish I can if this video works for us if it does it's going to be great okay a rectangular coil rotates in a uniform magnetic field. The coil is connected to an external circuit via slip rings and brushes. Induce EMF in the coil. Why are we using the word induce? Induce means when something is changing, something is producing. So the induced EMF in the coil can be measured by adding a galvanometer to the external circuit. The galvanometer will show that an EMF has been induced. An EMF is induced in the coil as it cuts the magnetic field. The pointer deflects first one way and then the opposite way and then back again. This indicates the size and the direction of the EMF is constantly changing because there's an AC generator. So if you're not making the coil to like come back, it's like moving on its own. It's going to complete a 360 rotation. Okay, so the coil is sometimes parallel, sometimes perpendicular, sometimes anti-parallel, anti-perpendicular. So the direction of the wave is going to be reversed. As a result of an alternating EMF, an alternating current is also produced as the coil rotates. This continues as long as the coil keeps turning in the same direction. So when we add the fuel to the generator, or when we add gas to the generator, it provides us an energy, and the generator has a You can say a turbine, or you can say a rotor, which turns out, and as soon as the coil is rotating, this thing is happening. My dear students, you need to remember this thing really well. Coil is vertical, coil is horizontal, coil is parallel, okay, to the field. Coil is parallel to the field, motion is perpendicular to the field, coil is original position. What do I mean to say? Look, the firstly, coil was vertical. Secondly, coil became horizontal. Thirdly, coil was vertical again, but the part which was up now is down. Okay, then the coil is horizontal again. The part which was on the right now is on the left, and now the coil is again vertical, and then the cycle is completed. So we have to show this on the graph. This is the most important part. The maximum EMF is induced when the coil is horizontal. Okay, the motion of the coil is perpendicular to the field. You have to remember this. Okay, jab coil perpendicular, when the coil is vertical, so the field lines are not being cut. Okay, field lines are not cut; they're passing from the coil. Are you getting it or not? Okay, but when
Yes.
the coil is horizontal, the field lines are cut. Okay, so maximum EMF is induced when the coil is horizontal, and the motion of the coil is perpendicular to the field. Okay, Master, so can anyone tell me for a complete 360 rotation, how many times you will experience the maximum EMF? Only two times, okay? One is going to be maximum with a positive value, and one is going to be maximum with a negative value because of the swapping of the sides of the coin. Is this clear? Make sense?
Yes, sir.
Yes,
Yes.
sir.
Okay.
And no EMF is induced when the position of the coil is vertical, the motion of the coil is parallel to the field. Okay, just because no field lines are cut and the coil is moving parallel to the field. Please screenshot कर लो, याद कर लो, याद कर लो, याद कर लो. यही आता है एग्जाम के अंदर. So we asked you to draw the graph for 3 marks, okay? यार मैं इसको चलाने की कोशिश करता हूँ if it works, then it's going to be great. चलते नहीं है इससे. Okay, sorry. जो ये समझाता रहेगा ना मैं ऑडियो में बताता रहूंगा कि बड़ी स्टाइल है. तो शेयर करना मुश्किल होगा बिकॉज़ आई समझ में. चले आप लोग जल्दी से ये वाला टेबल बनाइए. हाँ बिल्कुल. Draw this table in your notebooks, please, and the position of the magnets and the coil. Okay, my dear students, 0 degree rotation means where it is at the beginning. It does not show that it is either at horizontal or vertical. 0 degree means where it is lying. Sometimes 0 can be vertical. That means we are starting the motion vertically. Okay, and sometimes so if your coil is 0 and it's vertical, so the output voltage is going to be 0. Are you getting? So 0 degree is basically it's not the position of the coil. It's showing the angle of rotation. That's where are you starting from? Okay, so at this instant at 0 degree it's horizontal, but the journey can be starting from vertical as well. Okay. Okay. Draw this table quickly. 0, 90, 180, 270, 360. So what is the direction of the coil at 0 degree? Horizontal. क्या हो गया? Horizontal. ठीक है? Or you can say parallel. Okay. 90 degree जब इसको when you're going to rotate it 90 degrees, so it's going to be vertical. At 180, it's again going to be horizontal, but the problem is that the left side is going to be right side. Okay. Then at 270 is going to say to be vertical. Okay, and 360 is going to give you the same value where you started from. So can you guys tell me the values of the EMF or the output voltage at 90, 180, 270, 360? Yes. What is happening now? What is happening? 90? 90 पे क्या आ रहा है? What are we getting at 90? That Ramzan, the internet was so good. Now I think someone started stealing the internet. Oh, हाँ बताओ definitely. Screen is the screen is not sharing. Okay, let me share. Am I audible now? Am I audible?
Yes.
जी सर.
Yes, sir.
Okay. I say the screen must not be shared. I can't see it. Screen is not sharing now. Screen are you? Okay. I can't see it. Does it, okay. So, okay, for 90 degrees, what's the value of output voltage? No, it's going to be zero because it's vertical. Okay, so zero. No. So at 90 degrees, it's going to be zero. At 180, inductive. Okay. 270,
Zero.
zero. And 360,
Positive 10.
Positive 10.
positive 10.
Teacher, can you
Okay,
explain me again? I
very
don't
good.
understand.
When you have the coil horizontal, the EMF is going to be maximum. When it's going to be vertical, the EMF is going to be zero. Okay, so you can just imagine when you flip at 90 degrees, so it's going to be vertical. So there will be no EMF because there will be no cutting of the field lines. The field lines are passing, they're not getting cut. Okay, so this is 90. Okay, just imagine horizontal, then 90. Okay, then again horizontal, but this time this side will be coming over here. Okay, so if this was giving you positive 10 volts, so this is going to give you negative 10 volts. Okay, and then again it will become vertical, but this time if okay, so if this side was on the top, this side was at the bottom, but it's still being vertical, it does not make any difference. And then again when you flip it out, so that's going to be the same as starting. Okay. ठीक है अच्छा यहाँ पे थोड़ा सा गलत हो गया था anyways that won't make any difference so this is going to okay you guys can assume that as well like थोड़ा सा imagine करो उसको so this is horizontal and this is vertical so you can do this with your palm as well so when you have flipped it if this is your palm this finger when you make it vertical so this finger is going to go down that means the right side or this side of the coil is going to go downwards okay and then then okay and then you make it reverse so that's going to be over here okay and then it comes back so it's a complete 360 rotation all right get it 0 90 180 and then 270 and then 360 again okay and now one more thing is this clear to all of you
जी सर.
Yes.
Yes.
तो बहुत बहुत ज्यादा एनर्जी के साथ पढ़ा है इसको भूलना नहीं और गलत नहीं करके आना फिर it's going to be really the wastage of energy okay please my dear students please now look at this is going to be your curve okay now look Over there, over there, the coil was horizontal when we started, so it was giving a positive value 10. But in this graph, they're telling that the initial thing is vertical, so it starts from zero. Get it? So 0 degree does not mean that it is horizontal. 0 degree means from where you are starting. It could either be horizontal or it could either be vertical, depending. Okay, so if it is horizontal at 0 degree, you'll have the maximum EMF. If it is vertical at zero, you'll have the minimum EMF, that's zero over here. Okay, so look here. You're starting your you're starting your movement from here. Okay, so this is zero. Then horizontal max. Okay, then again vertical zero. Then horizontal, but the sides are flipped away, so negative. Clear?
Yes.
ओके अली बेटा आपको क्लियर है
Yes, sir.
तो मुझे सिर्फ ये बता दो कि जब हॉरिजॉन्टल होगा तो ईएमएफ मैक्सिमम होगा या वर्टिकल होगा तो ईएमएफ मैक्सिमम होगा
Horizontal.
so from the graph you can horizontal the maximum होगा very good ठीक है when the coil is horizontal you'll have maximum but the coil will be horizontal with the sides being flipped so it will be maximum but with a negative value okay beta you can see that it is maximum over here it's maximum over here and it is also maximum over here but with a negative value the negative value shows that the direction of the sides of the flip okay जी समझा दिया alhamdulillah this is completed so and alternating EMF corresponds to. You can take a screenshot of this. Okay. And what are the factors that affect the size of the induced EMF? Increasing the frequency of the rotation of the coil. Like you rotate the coil more faster, increasing the number of turns, increasing the strength of the magnet, and inserting a soft iron core into the coil. So if it's not just a coil, but an iron placed inside, so it's going to have the magnetic effect being more like of more strength. So these are the four things we can do. Can anyone read this? मेरा गला खुश्क हो गया बोलते बोलते. Back to the classes. Can anyone please? Ah, sure. When the coil is at vertical. Yes. Okay, भाई. So this is our AC generator. Okay, I hope it's all clear. For example, you need to be aware that an alternating current can be produced by a coil rotating in the magnetic field and magnet rotating with the coil. Both will induce EMF in the coil as they both ensure the coil will experience a change in magnetic field. Take a look at these nodes and trigonometric graphs if you need to brush up on your knowledge of sine and cosine graphs. देखो भाई साइन ग्राफ जो होता है that starts from zero and cosine graph starts from a non-zero value. So this is a sine graph and a cosine graph is going to be made if I make the graph for this one. Okay, let us draw the graph for this one as well. Oh no. Okay. Okay, they've already drawn the graph for this one as well. Okay. So at 0 degree, you're going to have the maximum, and then zero, and then the negative maximum, and then zero, and then the same value. Okay. So they will ask you to draw the what you can say, the position of the coil as well. Okay. So just remember that horizontal is going to give you max, and vertical is going to give you min. Okay. So let's start. Let's start the question. They asked. Is the screen sharing?
Yes, it's sharing.
Okay. Okay. So this is at 0 degree. Okay, this is the front view. This is a question being asked in the exam. Okay, you have to rotate it 90 degree. You have to rotate it 180. You have to rotate it 270, and then you have to rotate it 360, and you are going to draw the orientation of this PQ. Okay, start. This is the front view of the coil. Okay, like if you see the coil, it's going to be looking like this. Okay, so then you can use your palm to do this. Okay, P is your you're going to take your left or right hand, whatever. Like okay, take your right hand, and your thumb is going to be side Q, and palm facing upwards. आसमान की तरफ अपना हाथ करना है, ठीक है, अल्लाह के नाम पे दे दो बाबा वाला हाथ करना है, ठीक है, and then you're going to move it. हाँ, ठीक है, or you can use your left hand as well, no worries. अल्लाह के नाम पे दे दो बाबा, उल्टे हाथ से मांग के, ठीक है. तो अब क्या करना है? Okay, who's going to tell what's going to happen? बनाओ उसको, draw करो पहले. All of you must draw. 2 minutes. Draw. Without time. Draw first. तुम लोगों को मैं फिजिकल क्लासेस वाले जो है ना सारी चीजें कर रहा हूँ जैसे as if you are taking physical class. आशी बेटा समझ आ रहा है आपको?
जी सर.
अमान समझ आ रहा है? अमान चले गए मीटिंग छोड़ के, इज नॉट देयर. अमान नहीं है ना? It's not. नहीं है. Done? Okay.
Sir, may I tell you?
So let me just use the same diagram. Copy. Okay. Paste. 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 Okay. Lower. Lower. Okay. So at 0 degree, okay, so we are going to rotate it 90 degree, okay? So my dear students, let's rotate it 90 degrees. Done? The first rotation, 90 degree, okay? P on the top, Q on the bottom. All of you are having the same thing, okay?
Yes, sir.
जी
Now
सर यही
this
है
is, now this is all, okay? Now this is already in the position like this, okay? And now you're going to give it another 90 degree rotation, okay? Like this is already 90 degree, the same with which you're getting in for 90, okay? So now another 90. So flipped out. So P is on, okay? P is on the right and Q is on the left, okay? So this is when you get the negative EMF. Clear?
Yes, sir.
Okay. The next one is 270. So let me first flip it to the point where it was earlier. So, okay. And then we are going to give it another 90 degree turn. So another vertical line. So P on the bottom. Okay. This is going to give 0 again because it's vertical. Okay. And then when I'm going to have now, so it's going to be the same. Oh yes. So वैसे ही है मगर rotation के बाद वैसे ही है ना. So इसके बाद 270 के बाद we give it another 90 degree turn. So it's going to be 360 degree. I want all of you guys to raise your hands who are clear and who are not clear. I explain again, please. Don't be shy. Just be honest. अमान आ गया
I
वापस.
don't understand this.
जी शेयर मेरे मोबाइल बंद हो गया पावर ऑफ हो गया
तुम्हारा हाथ रेस हुआ भाई जब से नीचे नहीं गए. पहले इसको लोअर ज़रा पहले लोअर करो फिर रेस करो. Yes. Ziad, what were you saying, beta? Ziad?
Yeah.
What were you saying?
I don't understand.
You haven't understood this. Okay, no worries, no worries, no worries. So just look at this. We are going to rotate this. This is the initial position, okay? And you're going to rotate it 90, 180, 270, and 360. And you have to draw the orientations, okay? So when I just rotate it, okay, this is 0 degrees, okay? The initial position. When I rotate it to 90 degree, so this is, isn't this 90 degree?
Yes.
Okay, this is 90. So you have drawn this for 90. Now you give another 90 degree turn. So from the initial it's going to be 180, so, but from the middle point it's going to be 90 again. So you give another 90 degree turn clockwise. So it's horizontal again, but the side has been flipped up. Q on the left and P on the right. Is that clear?
Yes, sir.
Yes. Yes.
Okay, and then another 90. So like this, okay, and then another 90. So it's going to be, we give it a clockwise rotation, okay, by the way. All right.
Okay.
So if you want to have a greater EMF, what are the 4 things we are going to do, or the 3 things we are going to do? Who's going to tell? Shazin.
You can increase the speed of the coil rotation.
Very good. Increase the speed of the coil rotation. Number 2,
stronger magnet.
stronger magnet. And number 3,
Stronger magnet.
number 3. Okay. You guys are going good. Mashallah. Okay. The last topic for this is going to be transformer, and we'll end up the topic over here. Transformer is a device, is an electron.
सर वो मोर करंट के लिए ना
मोर करंट, आयरन इंसर्ट एंड आयरन को उसको छोड़ दो. मोर करंट तो उसमें होते हैं, डीसी मोटर में होता है. ठीक है. अब हम आ जाते हैं ट्रांसफार्मर के अंदर. ठीक है. अब तो रैंक का अफसोस हो रहा है. व्हाई इज नॉट देयर क्लास. So a transformer is an electromagnetic device, instrument used to either increase or decrease the voltage. Okay. So the part of transformer is quite simple. There are two types of transformers, okay? One increases the voltage and the other one decreases the voltage. And so easy. Okay. So we have got this is the coil, okay? And this is the coil. From the right side, you are receiving the current, okay, or the voltage, alternating voltage. Transformer works on alternating voltage, okay? The one from where it is receiving is called the primary coil. Okay? And the one from where it is giving the output, so this is the input, that's the output. Okay, so from where it is, so that's what you call the secondary coil. And this is the soft iron. Okay, why are we using iron? Because we don't want a permanent magnetism. We want something to be magnetized only when the current is flowing. Okay. So O levels, they have included something related to like electric bell or something. So I'll tell you the O level students separately that thing. So just need to remember that when there is an electromagnet का काम क्या है कि when electricity is flowing, it becomes a magnet. And as soon as you turn the switch off, so the current has stopped flowing and it becomes something which is not magnetized. Okay? Can anyone tell me the difference between the two coils you can see?
The number of
Small or big नहीं होता, more turns and less turns.
More,
ठीक है? शाबाश.
जी
ठीक है? So the first one is a step-up transformer. It's a step-up transformer. They can ask you to draw this as well for 3 marks. So you must know how to draw that step-up transformer. Okay? So the primary coilers are called NP and the secondary coilers are called NS. Alright? क्या
Yes,
चीज?
तो नीचे वाले ट्रांसफॉर्मर सेकंड ट्रांसफॉर्मर है
ये step down है. So NS is greater than NP. So what is a step-up transformer? It increases the input voltage. Okay. For this one, वो बताऊंगा ना, टर्न ज्यादा है ना. अभी तो आपने कहा ईएमएफ इंड्यूस ज्यादा करना है तो टर्न बढ़ा दो, कटिंग होगी ना इसमें. ठीक है, कटिंग होगी. जो प्राइमरी कॉइल से जो जो आपकी मैग्नेटिक फील्ड लाइंस निकलेंगी, those field lines are going to be cut by the secondary coil. Okay, getting? So this is a step down transformer. NS is lesser than NP. It decreases the output voltage. So what are the uses? Like, are they both significant? Are they both significant? The answer is yes. When we want to transmit electricity from the mains, from where it is produced, we use a step-up transformer because if we use a lower voltage, then there is going to be so much heating and there will be so much power losses. Okay, so we don't want electricity to be transmitted at low voltage. We just transmit at a very high voltage to reduce the power losses and to increase the efficiency. But if that voltage which is coming in the mains come to our homes and we are charging our mobile phones, just experience a burst the iPads and the mobile phones and the other classes are going to have. Okay, they are designed for 240 volts or 220 volts. How can the 10,000 volts come into your homes? Okay, just imagine that you are drying your hair with a hair dryer with a 10,000 volt, and unfortunately that your hands were wet. Inna lillah wa inna ilayhi raji'un. Okay, so that's why 220 volts and 240 volts. So we use a step down transformer. Step up, but the electricity is coming from the mains. Okay, and then it's a step down. Okay, is this clear to all of you?
Yes,
sir.
sir.
Okay, trying to explain in the
Sir,
very
इसका
simple manner. Okay, now
सर इसका डेंजर
two
तब भी हो
questions.
सकता है ना तब आप अपनी डिवाइस यूज कर रहे हो while it is charging.
बिल्कुल. अच्छा, A levels में they had transformer a few years back, but now they have omitted it. So this is the last time you're going to study transformer before you're going to your university. Okay, so it's just in your IDCSEs. So now you guys are going to write a 3 marker. Okay, I'm going to dictate it. I'm not going to write it so that all of you may be very alert. Okay, write out the question. अली ने इतने सारे thumbs up दिए भाई, क्या बात है अली. अली मैं तो तुम्हारी क्लास पार्टिसिपेशन को तरस गया हूँ. Like if you participate, I'll be so happy.
Yes.
Thank you so much. मुझे लगता है तुम लोग इस वक्त ज्यादा चार्ज होते हो. All of you. I can see the energy level much higher than it used to be in the day or the morning time. You know, there's a bad news. We are having our class. We are having our class. We are our math class early in the morning, 10 PST, 8 Saudi Arabia time. Impossible because I'll be sleeping at the time. नहीं कर रहा, नहीं कर रहा, नहीं कर, नहीं कर. I know. अली को इतनी सुबह उठाएंगे, कहेगा सर रमजानों में भी आपने सुबह उठाया फिर दोबारा उठा. Anyways, एक बच्चा है हमारे पास. हाँ भाई, अयान चला गया. अयान चला गया. ओके,
सर उसके यहाँ गेस्ट है.
अरे हाँ मेहमान है. ना हमें किसी ने बुलाया ना हमने किसी को बुलाया. Anyways, so describe the function of describe the working principle of a transformer. This is the question. First, write on this question, describe the working principle of a transformer, then leave at least 5 lines, and then write the other question, why a transformer cannot work on direct current.
सर आप रिपीट कर सकते हैं.
Describe the working principle of a transformer and why a transformer does not work on direct current. The Fed March paper 4.2 is there with us. Okay, thanks to Mr. Hashir. He has forwarded me the paper. And Hashir tried to get the paper 6 as well. I share with you guys right now, inshallah ta'ala, once the lesson is over. All of you are going to attempt it, the entire paper, because now we're done with the whole syllabus. Alhamdulillah. Okay? So we are done with the whole syllabus. Nothing is left. Okay? This was the last thing. Only minor things are going to be there. Okay? Some of the topics are obsoleted. So just be with me. We'll be now doing the past paper sessions and you guys can see. If there's any topic which you haven't covered, I'm like more than welcome to do them again with you guys. Okay? And now it's time for revision. All right. Describe the working principle of a transformer. Okay, start writing. When an alternating voltage enters the primary coil, when an alternating current or alternating voltage, you can write alternating current. When an alternating current enters the primary coil, so alternating, we just studied that there must be something changing. Either there will be movement or there should be changing. Alternating current changes the direction. So in the other way, we can say that the magnet is being moved up and down. There is no magnet over here, but the coil has become magnetized. Okay. So when an alternating current enters the primary coil, a magnetic field is set. Okay. A magnetic field is set. Alternating current continuously changes direction. You're going to use the word magnetic flux. Okay, ये याद कर लेना. Alternating current continuously changes direction, so magnetic flux changes.
Sir, flux.
Yes, FLUX. Magnetic flux changes, and magnetic field lines are cut by the secondary coil. Flux changes, and the magnetic field lines are cut by the secondary coil. Hence, an EMF is induced in the secondary coil.
Can you repeat the last part again?
Magnetic flux changes, magnetic field lines are cut by the secondary coil, and an EMF is induced. ज़ियाद की बस हो गई, उसने मिस लीव कर दी बेटा. चलिए. Okay, next question. Why a transformer cannot work on an alternating on a direct current? Okay, write down. For electromagnetic induction, for electromagnetic induction, there must be a changing magnetic field. There must be a changing magnetic field. Okay, so that the magnetic field lines can be cut. Direct current flows only in one direction. So no magnetic field lines are cut and no EMF is induced. Hence, yes, I'll stop sharing the screen. Okay, because I have to do something else. So direct current in one direction, okay? No magnetic field has a cut, and hence no EMF is induced. So that's why a generator cannot work on direct current. Transformer. Hmm. Hmm. G. 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 Exactly. That is the main idea. Clear? Any questions? Anything? Like you can take a few minutes to recap what we have done today, and then quickly tell me.
सर रिले का क्या करना था?
देखो रिले का काम होता है. रिले पहले था, मुझे नहीं याद कि रिले तुम्हारा एजुकेशन के अंदर अभी है. एनीवेज अगर है भी तो रिले का काम ये होता है कि रिले एक छोटे करंट को बड़े करंट में चेंज करता है। रिले इज यूज टू ऑपरेट एन एक्सटर्नल सर्किट। देखो मिसाल के तौर पे अब तुम्हें यूज कर रहे थर्मिस्टर, ठीक है, आपने थर्मिस्टर लगाया और थर्मिस्टर को आप यूज कर रहे हो। अब लेट्स सपोज आपके पास एक फायर अलार्म है। अब थर्मिस्टर क्या करेगा, जब टेम्परेचर इंक्रीज होगा तो थर्मिस्टर इज गोइंग टू लाइक reduce its resistance, more current is going to flow. And if you have a relay switch over there, so relay switch will have a smaller current flowing, and it's going to operate that smaller current into a large current, and the external circuit of the fire alarm is going to get operated. Is it clear or not?
जी सर क्लियर है।
ठीक है, ये कहते हैं
छोटे से बड़ा करंट करो।
छोटे से बड़ा करंट यूज करते हैं। Okay, बेटा,
जी सर।
राइट। हाँ भाई उमर, बोलो। हाँ बोलो बोलो। नहीं, डीसी डीसी मोटर में तो कहीं पे भी मैंने गोल गोल नहीं बनाया था, कभी भी नहीं। डीसी मोटर मैग्नेट को सेट
सर
करेगा।
सर
मैग्नेट
आपने
को सेट करेगा
जो
जनरेटर इसक के अंदर, जिसमें गैल्वेनोमीटर अटैच किया था। तो वहां पे भी देखो फील्ड लाइंस कट हो रही है ना। ठीक है, तो
सर
बेसिक हाँ, तो हम मैग्नेट को मूव करें ना, उसमें मैग्नेट मूव हो रहा है, फील्ड लाइंस एक ही तरह से कट होंगी। इसी वजह से तो आप इन बिटवीन आपके पास वैल्यूज नहीं है, या तो मैक्सिमम है या जीरो है। ठीक है, यही तो वजह है। ठीक है, और बताइए भाई।
सर आप स्ट्रेट रिंग कम्युनिकेटर और कार्बन ब्रश का पर्पस रिपीट कर सकते हैं?
मैंने स्लाइड शो की है और मैंने वीडियो शेयर कर दी, उसमें बहुत जबरदस्त बताया, उसको देख लेना, बिल्कुल क्लियर हो जाएगा। ठीक है, डू डू एंजॉय द वीडियो। ठीक है, स्लिप रिंग का तो सिंपल काम ये है कि टू प्रोवाइड अ कनेक्शन। ठीक है, बट स्प्लिट रिंग कम्यूटेटर हैज समथिंग व्हिच इज बीन आस्क्ड फॉर 3 मार्क, सो यार उसको अच्छी तरह से करना। ठीक है बेटा, और बताओ। अभी हाँ हाँ हाँ, डेफिनेटली इंशाल्लाह ताला। तो पास पेपर्स ही कर, तो पास पेपर्स ही करने हैं तो जी बिल्कुल बिल्कुल बिल्कुल। तो या तो मैं आपको टॉपिक असाइन कर देता हूँ, नहीं ये तो करवाना है, ये मैग्नेटिज्म तो आपके ऊपर छोड़ ही नहीं सकते। बट बिकॉज अल्हम्दुलिल्लाह आई एम नॉट अ टीचर हु हैज नॉट गॉन थ्रू द पास्ट पेपर्स, काफी एक्सपीरियंस हो गया, लाइक आई हैव गॉट लोड्स ऑफ एक्सपीरियंस अल्हम्दुलिल्लाह। सो स्पेशली पास्ट पेपर्स के अकॉर्डिंगली तो लाइक आई कैन से लाइक 2016 2014 से ऑनवर्ड्स पास्ट पेपर्स आर अल्हम्दुलिल्लाह ऑन माय टिप्स। तो the way I've taught you guys is going to be really helpful for solving the past paper। ठीक है, इवन अब आप इंशाल्लाह खुद से पास पेपर्स भी कर सकते हो। ठीक है, ट्राई करना। every year like question number 7 or question number 8 or question number 9 is from this magnetism। ठीक है, मैग्नेटिज्म के 2 क्वेश्चंस भी आ जाते हैं, क्योंकि मैग्नेटिज्म के 3 पार्ट्स होते हैं। एक मैंने पढ़ा था ना, मैग्नेटिज्म था पहला वाला, फिर दूसरा वाला था इलेक्ट्रोमैग्नेटिक इंडक्शन, और तीसरा वाला दूसरा था इलेक्ट्रोमैग्नेटिज्म, और तीसरा था इलेक्ट्रोमैग्नेटिक इंडक्शन। ठीक है, लेफ्ट हैंड रूल वगैरह इसमें आया था। तो ठीक है, और सवाल।
Sir, for Feb March for chemistry, have you only found paper 4?
हाँ ना, अभी तक पेपर 4 ही मिला था, मुसीबत।
Sir, I found for chemistry I found paper 2 and 6, but it's not a very clear PDF.